Hello everyone. My presentation today is on a predictive analytics approach to customer attrition in the telecommunications sector. My name is Gautam Krishna Sai Redangi, and this project was completed under the guidance of Professor Dr. Chaojie Wang. So to begin, why does customer churn matter? Customer churn, also known as attrition, is simply when customers cancel their service. It's a major drain on revenue and a company's market standing. This is because, as most of us know, acquiring a new customer is far more expensive than keeping an existing one. The goal of this project is to stop being reactive to churn and become proactive. This leads to my three main objectives. First, to build a predictive model that can accurately forecast customer churn using historical data. Second, to identify the key drivers of churn by analyzing which customer factors are the most important predictors? And third, to compare several machine learning methods, specifically decision tree, random forest, and XGBoost, to determine the most effective model for this problem. Let's look at the data used for this project. The source is a historical Telco customer churn dataset. It contains 7,043 customer records and 21 different features. These features fall into three categories: demographics, such as senior citizen, partner, and dependents; services, which include things like internet service, online security, and tech support; account info, like the customer's contract type, payment method, and monthly charges. Our target variable is churn, a simple yes or no label for whether the customer left. The key challenge with this data set is that the data is imbalanced. A large majority of customers did not churn. This makes it difficult for a model to learn how to predict the rare yes churn event, as it might be biased towards just guessing no. Moving into the exploratory data analysis, this first chart shows the imbalance I just mentioned. This is a count plot of our churn target. We can clearly see the target is imbalanced. The large blue bar shows that 5,174 customers did not churn, while the smaller red bar shows that 1,869 customers did churn. This imbalance is our main technical challenge, and it's why we must use a technique like SMOTE, synthetic minority oversampling technique, to get a reliable result. Continuing with the EDA, this plot shows the distribution of customers' tenure, or how long someone has been a customer. What's interesting here is that the tenure is split into two main groups. On the far left, there is a large number of brand new customers, and on the far right, there is a large number of long-term loyal customers. This U-shape suggests that we are losing a significant number of customers before they become loyal. This heat map shows the correlation between the key numerical features. As we would expect, tenure and total charges are very strongly correlated with a value of 0.83. This makes sense. The longer a customer stays, the more they pay in total. Now we start to see some clear predictive signals. This chart shows the churn rate based on senior citizen status. Senior citizens churn at a rate of 41.7%. This is nearly double the rate of non-seniors who churn at 23.6%. This makes senior citizen a very clear and important predictive signal for our model. This chart shows even a stronger signal. Here, we see the churn rate by contract type. Customers on month-to-month contract churn at an alarming rate of 42.7%. In stark contrast, customers on 1 year contract or a 2 year contract are significantly more loyal. This is likely the strongest driver we have found. Based on the EDA, here is the data preparation process I followed. I converted all categorical data like yes or no or contract types into numbers so that the machine learning model can understand them. I use the SMOTE technique on the training data only. This creates synthetic yes examples to balance the dataset, which stops the model from just guessing no all the time. Finally, I split the data into 80% training set to build the model and a 20% test set to check its real-world performance. This slide outlines the process for designing and selecting the final model. First, I trained three models with their default parameters. A decision tree which got 78% accuracy, a random forest 84%, and XGBoost 83%. This was done using five-fold cross-validation on the balanced SMOTE training data. Based on this, the random forest was selected as the champion model due to its high 84% baseline accuracy. I then perform a randomized search CV on that random forest model to optimize its settings for our specific data. The result was our final tuned random forest model, which achieved 85% accuracy in tuning. This slide just shows the text output from that initial baseline comparison. You can see the decision tree cross-validation accuracy at 0.78, the random forest at 0.84, and the XG boost at 0.83. This is the most important slide for evaluating our final tune model on the unseen test data. First, the overall accuracy score is 0.78 or 78%. But for a churn problem, we care more about recall. Our recall for the churn class labeled 1 is 0.60 or 60%. This is our most important metric. It means we successfully find 6 out of 10 customers who are actually at risk of churning. Next, our precision is 0.58 or 58%. This means that when our model flags a customer as at risk, it is correct 58% of the time. The key business takeaway is that the model is solid, proactive tool. It successfully identifies the majority 60% of churners, allowing the company to intervene with retention offers. To make this model useful for the business, I built a web application to deploy it. This is a screenshot of the Streamlit app. The retention team can now go in, input any customer's details like their tenure, contract type, and so on, and get an instant actionable churn risk prediction. In this example, the customer entered has a 72.1% probability of churning, which is flagged as high risk. To summarize my findings, my model successfully identifies 60% of at-risk customers, which is a 60% recall. And I found that churn is primarily driven by the customer's contract type, their tenure, and their senior citizen status. The Tune random forest proved to be the most accurate and effective model with a final test accuracy of 78%. And a Streamlit application is built and ready for use by the retention team to get proactive predictions. Thank you for your attention. I also want to thank Professor Dr. Wang for his guidance toward this project. How my application looks like. On the left, the user can give inputs like the gender, if the customer is a senior citizen or not, and about all the account informations like the tenures, the contract type, the monthly charges, and if the customer is subscribed to any services like uh, tech support, streaming TV, etc. If you go all the way to the down, there is a button called Predict Churn. On clicking it, it will display the input data which is provided by the user along with the prediction result. Here, it has predicted that there is no churn, and it also provides the probability for each label. Here, it says that for no churn, the probability is of around 71.2%, whereas it shows that there is 28.7% of probability for churn. Thank you.